It boosted like an 808. My product Cartesian. This is maximum subarray, sum with one deletion. Given an array of integers, return the maximum sum for a non-empty subarray with at most one element deletion. In other words, you want to choose the subarray and optionally delete one element from it such that there is still at least one element left and the sum of the remaining elements is maximum possible. Note that the subarray needs to be non-empty after deleting one element. Okay, so you can't just you can't return the sum of an empty subarray. Okay, so for this problem, right, we have 1, -2, 0, 3. Obviously, we should skip -2, so we add 1, add 0, add 3, we get 4. For this problem, since we can only skip 1, right, it's best to just choose 3, right, because I'm never going to get this 1. If I want to use this 1, I'm going to have to use this -2, which can get me to -1 plus 3 is 2. So it's best to just use 3 alone and not skip anything. In this problem, I can't just choose one element and then skip an element, so I might as well just choose one element alone, right? You can't return the sum of an empty subarray. All right, so for this problem, we have to choose a continuous subarray, and the only kind of additional aspect is that we can skip one thing, right? So really what this problem is if I thought about it in terms of the elements, like if we looked at this example here, right? We have these nodes, 1, -2, 0, and 3, okay? And from any node, right, I can either skip it or I can go to the next node. From the next node, I have the choice of going to the next node or skipping. And from the next node, I have the choice of going to the next node or skipping. Right? And that means that for this problem, right, I'm just trying to find the maximum path in this system, right? The maximum path in the system starting from any state. Right? Like the maximum path in this system starting from this state is here to here, here to here, and then across here, right? And if we were to draw this, so this makes sense, right? But I guess the only issue with this problem is that you can only skip once, right? I can use a skip edge, but I can only do that once, right? When I use, for example, this graph is almost correct, but if we thought about this example, right? So I'm looking at example 2 here. Why did I do that? Right, so if we look at this example, well, that wouldn't do it either. So let's say we had this as an example here. You know, you may feel inclined to say, okay, well, from any node, I have the choice where I can go to the next node directly or skip, go to the next node directly, or I can make this cleaner, or skip, go to the next node directly, or skip, go to the next node directly, or skip. Right? Well, then what would be the longest path in this graph? Well, if you started from this node, you could go here to here, but then you could go here to here. So the issue here is that this graph doesn't encapsulate the fact that I only get one skip, right? I don't get 2 skips, I only get 1. So in this system, I've already used my skip by using this graph here, so I can't skip again. So this system needs to somehow address for the fact that I've already used the skip. And if I've already used the skip, then I can no longer skip and I just have to use the elements in front of me if I want to consider a maximum path. So in order to do that, we'll take this system of graphs, right? And what we'll do is create a copy of it where the copy will be the state where we've already used the skip. So essentially what I'm saying is, if I get down here, that means I've used the skip. If I'm up here, that means I haven't used skip. So if I haven't used the skip and I'm in this state, what can I do? Well, I can go to the next node directly, or I can skip. And I can do that for every single node at the top, right? I can go to the next node directly and not use my skip, or I can decide to use my skip in this state, go to the next node directly, or use my skip. What about at the bottom? Well, if I'm at the bottom, I can't skip anymore. My only choice is to go to the next node directly. Right? So now this system, if I wanted to find the maximum sum, well, if I was to try to draw this same... Wrong thing. Did I copy it and I didn't? Yeah. Right, if I try to do 1 to 1 to 1 like I had before, notice that's no longer possible in this new graph because I've captured the fact that, you know, there's a different state, right? There's a state where I'm at this node and I haven't used the skip, and there's a state where I'm at a node and I have used the skip. So that's kind of a aspect of these problems you should think about, right? Is like, sure, I have these states being the numbers that I'm at, but is there more information that would increase the number of states? Well, there is, right? Because there's a state where I have used the skip, and there's a state where I haven't used the skip. And that's true for any node that I'm at. I'm at this node, and either I have skipped already, which means I'm down here, or I haven't used the skip already, and that means I'm up here. So if we try to make that again, right, notice now that we've graphed it, we've modeled this graph in such a manner that it encapsulates the fact that I've already used the skip, so I can't skip again. So this problem really comes down to, how do I model this problem as a graph such that it encapsulates the fact that I only get one skip, right? If I had infinite skips, right, then this old solution would be correct. But I don't have infinite skips, right? I can only skip one thing. So since I can only skip one thing, I have to draw it like this, where that information is captured, right? These bottom nodes represent you skipped. The top nodes represent you haven't used the skip yet. So then this problem really comes down to just simple dynamic programming, right? I would look at any state. I would start from the very left. And I would look at any state and I'd say, what's the best path ending at this state, right? What's the best subarray ending at this state? Well, the best subarray, let's just go through. So we look at this node first. We'd say the best subarray ending at this state is what? Well, it's just itself, right? It would have to include itself. So that would give us 1. What's the best subarray ending at this state? Again, that would just give us 1. And then we look at -2. The best subarray ending at -2, well, it'd be a terrible subarray, but at least it would be greater than -2, right? Either the subarray is -2 itself, or it's 1 leading into negative. The best subarray ending at 1 leading into -2, right? Which is going to give us -1, right? So that means for this option, right, I can look at this previous node and get information from that, or I can just look at myself. So I can look at all the arrows going into me to make a decision about what I should do. And then the same thing here, right? I could look at myself, but I'd also get better information from 1. So I might as well just use that, -1. Okay, now it's where it's going to start getting a little bit more interesting. We look at 1 here. The best subarray ending at 1. Well, if I try to get the information from this previous node, right, the best subarray ending at -2, that provides me with -1. So I shouldn't use that information, right? If I include -2, if I include the best subarray ending at -2, it's going to make my score less than if I just used myself alone. So the best subarray ending at this 1 is just 1 itself, right? What do I keep doing that? It's just 1 itself. So what I'm saying is I'm not including this -2 here because I have the choice, right? generally, right, for any node, right, what I'm basically saying in this problem, if you have a node X and a node Y, the way that we're processing this system is the value at Y will be the maximum subarray ending at Y, right? So it'll be some subarray with Y in it. So when the next element is X, X can make the decision, well, if I want to include Y, that would mean the maximum subarray is Y, and then I include X as well. Or I can just not include Y and say, okay, Y is bringing my score down, or I can just use X, right? So it's the maximum of these, right? Adding in an additional element, it's either going to be the maximum of the subarray ending at my previous element or the maximum of just me alone. So that's the general idea for that. We'll keep this around because so X equals the maximum of this. We're going to keep this around because in a second I'm probably going to use this generalized graphic again to prove something else. Okay. Now this is where the bottom gets interesting. So remember, we just calculated this saying that, okay, the best subarray ending at this one is just the one itself. We don't want to include the best subarray ending at the previous element because it'll just bring our score down. Right? My neighbor's just bringing me down. Now when we look at one, well, this one has options, right? This one can use this previous subarray, but that's just going to give it -1. It's going to bring its score down, right? It's the same case here. But it also has this edge here that it can consider. And that would provide it with 1. So the best subarray at this point would be 2, right? Because it gets 1 from here and it gets 1 here. So it skips this element. All right, so generally what that means is if you had an element Z here, that would mean X was here, right? For Z, the maximum of this Z here is either Z itself, right? Just not including anything before it. So that means you just choose your own element. So Z equals the max of the value of Z itself. I don't know why this notation's a little bad. Or I could skip X, right? Maybe X is causing issues here. So I could just skip X. So I could take all the elements up to Y and then negate X, right? Not negate, just not utilize X. I don't want X. X is bad for my situation. So maybe if I skip it, so that subarray here, right? Because everything up to Y is the best, well, is the best subarray up to Y, right? So I set Y to the best subarray up to Y, so that when I skip X, I get here, so then I can attach myself to the best subarray up to Y and attach Z to it. Or I could attach myself to the best subarray up to Y where Y has skipped some series of elements, right? So these are not the same. This is the subarray. Down here's a subarray where I skipped some element to get the maximum subarray ending at Y, versus this is the maximum subarray ending at Y where I didn't skip an element. So I can use, I can make either of those decisions. I can take, at X, right? So I can take the maximum subarray ending at X where I skipped some element. I can take the maximum subarray ending at Y where I didn't skip an element, and that would mean that I skip the next element to get here, or I can just take myself, okay? So that's a generalized example here. So that's why you get to this solution here, right? So for 2, for this element, the best thing I can do is just myself, or I can skip this -2, or I can use the best subarray ending at -2 where I skipped somewhere previously. And then you just go through this whole solution, and I think you kind of see generally how this problem works. Okay, so there's for these kind of problems, I like to use, obviously this is end time, right? Because I'm just going to look at each node twice, I guess, and look at previous information and try to get to the solution. I'm going to do non-constant space, which is a manner in which I like to approach these problems. Approach the problem using dynamic programming, create your entire catch using non-constant space, and then see if the nature of the problem will allow you to just use a couple variables to capture the information you need at each iteration to create a situation where it is constant space, right? So basically what I'm saying is use non-constant space just to get your problem working, and then see if it can be tweaked to use constant space. So that's a common approach that I've found usable and just more intuitive. So let's go ahead and get right into it. So we need information for all the nodes twice, right? Because there's a haven't used the skip state and there's haven't used the skip state. Have to use the skip state. So we'll just create that catch. We'll call it D. Now I'm going to make it length of array plus 2 just because, you know, we looked at this as D. Right, so let's look at this situation here. Let's erase some of this stuff. Let's say, what's the general formula, right? If this is D, this would be D0, this whole thing. Right, and this would be D1. I went D1, would be this whole thing. Right? So this is D00, D01. So generally, right, if we said I was here, if this was I, so I being an index in the array, what is the value of this system here? Well, it's going to be D at 1 at I equals the max of the array at I, right? Because that's this value. Maybe I should have done it the generalized way. I don't know. And then I could take the element that comes just before me. Do array at I could do D at 1 at, well, what's this previous element with respect to this element? Well, that's D of 1, I minus 1. Plus this element. Or I could take D0. Well, what is this element with respect to this I? Well, this is I minus 1, I minus 2. D0, I minus 2. Or I could do array at I plus D0, I minus 2. Right, so that's all the information I need to solve for this. For this one, right, for any element here, it would be the max of itself plus the max of the previous one, right? So for this element, if this was I, D0 at I equals the max of, you know, you have the element alone, and then you have the element plus the previous, which is D0, I minus 1. Right? Because this is, if this is I, then this is I minus 1. So these are generalized formulas for how this is going to work. So let's keep track of that and consider that when we solve this problem. All right. Now, why are we doing plus 2? That was the first question. Because, right, if we solve for this, we're going to go -2 to the left. So we don't want to basically overcount. We don't want to overreach our boundary. So we're just going to kind of create this little buffer of I plus 2. We're just creating a buffer of plus 2. That way, when you try to check something negative, it doesn't wrap around and pull values. Just basically, since I'm going I minus 2, I'm going to do plus 2 to create a buffer. Okay. And then we do that for range 2, right? Because we're just creating 2 copies. So we're going to look at each number. I guess I'll do index I and the element in the, let's enumerate the array. And then let's just do this formula. So D of 0 at I equals the max of the element and the element plus the previous subarray. So D0 I equals the max of the element and the element in the previous position, right? So this is going to wrap around because it starts at 0, so this will be -1. So if we have 2 0 buffers on the right, it won't cause any issues. And then if we did d1 of I, what do we say that equals? It's the max of the element itself, the element plus skipping a previous, plus this side here, so that's d of 1I minus 1 plus element. So d of 1I minus 1 plus the element. Or d of 0 I minus 2, so we skip something plus the element. And then we just do that for each system, and then at the end we just return the max of each row. So we'll look at each row for D and D, right? Because we're looking at it could end at any point, right? So we're looking at some subarray that ends at some point. But we don't want to consider the last two elements because the last two elements are 0. We never even populate those, right? Because we go to the length of the array. So we don't want to consider those zeros. So we'll just do -2 here. Okay. All right, if we, just so that we see what's going on. Yeah, no, that's going to be confusing. So that's fine. All right, so let's go ahead and submit that. Ooh. What have I done wrong here? Everything seems, no. D0 of I is the maximum of the element. Because it is skipping 2, you notice that? What am I doing wrong here? I don't know. Oh, because I have to add the element in. I can't skip the previous element. Right, and I wrote that here. I just forgot to put that here, right? D0 of I equals the max of the element and the element plus the previous element. Okay, so good. This works, right? So what's the time and what's the space? Okay, so for, let's say n equals the length of the array. Right, for time, we just have O of n. Because we just look at each element and we do a constant operation and a constant operation. So we do n constant operations, just O of n. And then for space, well, we have to create this decatch array, which has the size of the array twice. So that's 2n, but that's big O of n as well. So this is a O of n time, O of n space. But something that you'll notice, right, is that we only need to keep information about a few things, right? We need to keep information about the current iteration. So we need to keep information about D0 I. We need to keep information about D0 I. We need to keep information about D0 I minus 1, right? I'll call it I1. So this is I minus 1. So D0 I minus 1. We need to keep information about D0 D1I. Sorry, so that's this. We need to keep information about this here. We need to keep information about D1 I minus 1. And we also need to keep information about D0 I minus 2. But these, 5 variables, I guess? This might be adjusted in a minute, right? But these 5 variables, that's all we need to keep count of. So we don't need to keep count of everything that's ever occurred since the beginning of the array that we processed. Just these 5 things, regardless of how big the array is. So if we can somehow keep track of just these 5 things for the iterations of this loop, we can make this a constant time algorithm. Okay? So how are we going to do that efficiently? Well, D0I minus 1 for the next loop iteration becomes the max of this for the previous iteration. Okay. That same thing with I minus 1. So if this was I minus 1 in the next loop iteration, or for 1, I minus 1, this will be I minus 1 in the next iteration. All right. And then I minus 2 is I minus 1 in the previous iteration. But that would be I minus... Is that right? That's why it's so confusing. Okay, if I minus 2 is I minus 1... No, okay, so that needs to happen after. So this can actually happen first. So I'm not like intuitively thinking about the relationship between these things. I'm just trying to replace using these 4 constant pointers. Or actually, there's just 3 that we need. Okay. And then we'll just say that the max. So now we're no longer, we'll just keep track of what the maximum value is. So we'll just call that M, and that'll be the max of definitely whatever these things are. And then we'll just return that at the end. And then we'll set these variables in the beginning. Okay, so that was me just trying to kind of cram through making this constant without actually thinking about the implications. Fudge. And the fact that I didn't think about it really screwed me now because I don't know. Oh, I forgot to put, this is I minus 2. Oh, shoot. Where did I? Okay. Here. Okay, so let's comment this out and let's see if that works. So that's me literally just trying to see how I replace variables. Again, I'm not thinking through... Ah, fudge. Maybe I should be thinking through because I'm apparently an idiot. So the value here becomes the maximum of the element. Whatever I think the previous is in the element would be the same thing. And the same thing. Now the previous skip is this previous skip. And then this just becomes the element plus whatever it previously was. Oh, because I haven't updated what M is. So M starts at float negative infinity, I guess. All right, so this is what's problematic when you try to make something constant, because it's not that easy, but you know, you can tweak it. The problem is, are you going to capture everything in the interview? Okay. So this is saying 0, right? But you can't skip, so you have to leave at least one element. So there's something in here causing it such that, yeah, so setting D0I to D01, this starts at 0. So then if you take the maximum of that, but that's just the previous element. So, well, no, because I have the element. Something here is getting updated inappropriately. Okay, there we go. So we don't need to consider that, right? So either the maximum of taking a skip or not taking a skip, getting to the end. Right? Because it's possible that you get to the end and never take skip. Blah. And technically, so that means that this is now O of 1 space. So that's what I had to do to make this O of 1 space. It's much harder to read. Maybe someone could look at this and be like, come on, man, you're making this really ugly. But screw you, man. You don't know what I go through. Yeah, I think I can make this one line actually. So that's pretty much it for the solution. If you want to stick around and watch me make this more confusing than it already is, go ahead. But I'm just going to make this as short as possible because I hate myself. All right, and that means this can go on one line. Error. No, okay. So this is technically speaking, this is now a 3-line solution that doesn't work. But yeah, whatever. I don't care. I got it right. It's done.